In this video, we are continuing section 1.1 on numbers and sets, and we are going to focus on intersection and union, so giving a review of these terms. Okay, so I want to start with an example right away. Let's represent the set by an inequality, a number line, and an interval notation. So the first problem says, well, all the numbers less than 2. So in part A, as an inequality, I could represent my number with a variable like x, and I need x to be less than 2. Okay, and that's the answer to A. I got it as an inequality. So on a number line, let's draw our number line. I would put a tick mark at 2, and because x is less than 2, I'd put an open circle at it. I don't want to shade it in because it's not allowed to be equal to 2. And then I want to shade the stuff to the left of 2 because those are all the values that are smaller than 2. Okay, so I got my number line, and in interval notation, the shaded numbers start way over here on the left. So they go all the way to negative infinity. Okay, infinity and negative infinity are always, they always have parentheses in interval notation because I never actually reach them. They're not actual numbers I can reach, so I can't put a closed bracket at them ever. Okay, and then comma, my interval goes up until 2. It includes all the numbers up until 2. 2 is also not included, so I put a parentheses. Okay, that's it, my interval notation. Okay, so just to recap, plus and minus infinity always have parentheses, like we said, because they're not actual numbers we can reach. Okay, next problem. Now I want to do all the numbers greater than or equal to 2. So as an inequality, I would write x for my number, and this time it's greater than or equal to 2. On a number line, I would draw my number line. I could put a tick mark at 2. Greater than or equal to, so this time I draw a circle that's shaded in. It could be equal to 2. And I want to shade in all the numbers that are greater than or equal to 2. So these are all the numbers on the right of 2. Okay, so I got my number line shaded. And in interval notation, my interval starts at 2. This time I put a closed bracket because it is allowed to equal 2. It includes 2. And then all the way until positive infinity. Remember, positive infinity always has a parentheses, just like negative infinity, because it's not an actual number I can reach. Okay, all right. So now let's review intersection and union. So with an example, let's say that A, these curly brackets just mean I'm talking about a set. So a set is something that has some objects in it. So the set A has the numbers 1, 3, 5, and 7. Those 4 numbers in it. And B is another set with the 4 numbers in it, 5, 6, 7, and 8. So these are 2 sets. So the first definition is of an intersection. The intersection of 2 sets. And the way I denote an intersection is I write A, I write B, and then I write this kind of upside down U shape. That denotes an intersection. An intersection contains the elements that are in both A and B. They have to be common to both of the sets to be in the intersection. So in my picture here, let's say this first circle on the left is A and the circle on the right is B. The intersection, the stuff that's common to both, well, it's the stuff in the middle. The stuff of this overlap, that's the intersection. So the intersection is this overlap area. Okay, so what is that in this specific example? This example up here. So what are the elements that are common to both? So if I write A upside down UB for intersection, put my curly brackets to indicate it's a set, and the numbers that are common to both sets are 5 and 7. And then I close my curly bracket, and that's my intersection. Okay, now let's talk about union. The union of A and B, and this is denoted with A, B, and now I just put kind of like a upside down version of the previous symbol, just kind of like a normal looking U, but without this little tail. A union contains the elements that are either in A or in B or in both. So if this first circle represents A and the one on the right is B, well, the union contains everything in A, the whole circle A, but also everything in B, as well as the stuff that's in the overlap, but we've already counted the stuff in the overlap. It's already shaded in. So all the stuff that's shaded here is the union. Basically everything in A, as well as everything in B, all of that stuff put together. So if I do that for my specific example up here, basically everything that's in either one of the two sets goes in the union. So curly brackets, so what goes in it? 1 goes in it, 3 goes in it, and then I have 5. I'm just going to go in increasing order. 5, 6, 7, and 8. Okay, and that is my union. All right, let's do some more examples. Okay, all right, so in this next example, example 5 says, I have some what are called some and statements. It says something and something. Represent the and statements on a number line. And in example 6, it says, I have some or statements. Represent those or statements on a number line. Okay, so part A. In part A, it says, well, x is less than 2 and x is less than 8. I want to denote the numbers that satisfy both of those, because it says the word and, on a number line. Okay, so, well, how do I do this? Let's first draw a number line for each one of them individually. So I'll draw 2 number lines, one for the first, one for the second. So in the first one, I put a tick mark at 2, open circle, because it's not allowed to be equal to 2, and I shade the stuff to the left, because it says x is less than 2. The second one says x is less than 8, so 8 is bigger than 2, so it should go to the right of where 2 is. Open circle again, because it's not allowed to be equal to 8. And I want the numbers less than 8, so I shade in the stuff to the left. So that's x is less than 8. Awesome. Okay, so the word and represents an intersection. Like, to be in an intersection, I got to be in the first set and I got to be in the second set at the same time. So and means intersection. So as we saw in the picture of intersection above here, well, with an intersection, I'm shading in the values that are common to both of the sets. So in my picture, that are common to both of my number lines. Okay. All right, so what I'm going to do now is I'm going to draw a new number line. A new number line here. Okay, and on my number line, I'll put the numbers. You know what? Let me line it up with the first number line. Let me line it up with the 2 number lines I have up above. Okay, and I'm going to put 2 on it. I'm going to put 8 on it because those are the numbers I see above. And I'm only going to shade in the numbers that were common to both of the number lines up top. Okay, so up top, you know, if I think about numbers like the stuff to the right of 8, well, those are not shaded in either one. So that's not going to be shaded in my final number line either. What about the stuff between 2 and 8? Well, those are only shaded in one of the number lines. So it shouldn't be shaded in my final one. And then what about the stuff to the left of 2? Well, those are shaded in both of them. It's common to both. So those should be shaded here. Okay, so I'm going to shade them in. Let's shade them in. All the things to the left of 2 are common to both. What about 2 itself? Well, 2 itself is shaded in the bottom one, but not the top one. So that should remain open. It is not common to both of them. Okay, so that is my final number line. I have drawn a number line for this and statement, for this intersection of number lines. Okay, let's do example 6 at the same time because it involves the same inequalities, just merged with a different word, the word or. Okay, so the word or represents a union. So this time I'm taking the union of these 2 number lines. Okay, so I'm going to draw a number line to represent this union. So with the union, as we saw in the picture up above, well, we take everything in the first set as well as everything in the second set. We shade it all. Okay, so we are going to shade in the values that are included in, well, at least one of the number lines. Basically, we shade everything in the first number line, everything in the second number line, all of that gets shaded. Everything that's in at least one of them is going to get shaded. Okay, so I'll put a tick mark at 2, and I'll put a tick mark at 8. So the stuff to the left of 2, is that shaded in at least one of them? Yeah, it's shaded in both. So that should definitely get shaded. Stuff to the left of 2 definitely gets shaded. What about 2 itself? Well, that's shaded in at least one of them. It's shaded in the bottom one. So 2 should be shaded in. 2 is shaded in. What about the stuff between 2 and 8? Well, that's also shaded in at least one of them because it's shaded in the bottom one. So that should get shaded. What about 8 itself? Well, that's not shaded in either one. So that should be open. And then the stuff to the right of 8 is not shaded in either one either. So that's not going to get shaded either. Okay, and there is my OR statement as a number line. I've taken the union of these two number lines. All right, let's do another example. So what if I flip some of these inequalities? In part B, it says x is still less than 2. So let's draw that. But now it's going to say x is bigger than 8. So x is less than 2. So open circle at 2, it's not included. And x is less than 2, so that's to the left. I'll put a tick mark at 8. And then bigger than 8 means open circle, not included. And I shade in the stuff to the right, because that's the stuff that's bigger than it. Okay, and now I'm going to merge them with the word and. And means I'm going to take an intersection. So I'm going to take an intersection of these. So the intersection, I have to shade in the values that are common to both. So which numbers were shaded in both of them? Well, it turns out nothing. There's nothing that was shaded in both. Like the stuff to the left of 2 is only shaded in the top one. The stuff to the right of 8 only shaded in the bottom one, but not both of them. And then, of course, in the middle, neither one is shaded. So as a result, when I merge them with an intersection, my number line is empty. There's nothing in it. Or I could say, well, there's no solution here. No values of x are going to get the job done. Okay, so that's a little weird, but that could happen. A number line can be empty, technically. Well, what happens if I take the union, if I combine them with the word or instead? So if I take the union of these, I'm draw an arrow, and I form a number line. If I take the union of these, I'm going to shade in any value that shows up in, at least one of them. Basically shade anything in the first one, anything in the second one, all of that stuff will get shaded. Okay, so that means the stuff to the left of 2 gets shaded because it was shaded in the top one. The stuff to the right of 8 gets shaded because I was shaded in the bottom one. And that's it. I've shaded everything that showed up in at least one of the number lines now. Okay, that's my OR statement. Alrighty. All right, let's do a couple more examples. So a couple more examples. All right. So for these next two, I'm going to, again, flip some of the inequalities a little bit. But I first want to give you an opportunity to try these. I want to give you a little bit more time for C and D. So for these examples together, I want to give you about 3 minutes to try them. The time that I give you to pause videos like this and try problems is maybe the most important time of the videos, because ultimately the goal is for you to be able to get to the point where you understand how to do problems like these on your own, and not simply just watching me work out the examples. To really take advantage of this time to try these problems on your own. We'll have a lot more time like this in class to try problems, but this is a great point to start that. All right, pause the video in 4, 3, 2, 1. Pause it and try these. 3 minutes might not be enough time to finish all of them, but that's okay. It's really about thinking about what the key steps are and trying to make some progress. All right, so hopefully you did that. Hopefully pause them to try these. Let's talk about them. All right, so for C, let's draw a number line for each of these statements. So first number line, second number line. So first I have x is bigger than 2. So open circle at 2. Bigger than 2 means shade the stuff to the right. Shade the stuff to the right this time. And then x is less than 8. So 8's bigger than 2. That's why it's on the right of 2. Less than 8, open circle, it's not included. There's no equal sign at 8. Less than 8 means the stuff smaller than 8. That's to the left of 8. Okay, so I want to merge these with an and, which means take an intersection. make a number line where I'm going to only shade the values that are common to both of the previous ones. Well, what's common to the previous ones? It's just the stuff between 2 and 8. Only the stuff between 2 and 8 is common, so that should get shaded. 8 is open and 2 is open, because neither of those was shaded in both. Those were only shaded in one of the two number lines. Okay, so that's my intersection. That's my AND statement. Okay, now let's form the union. That's the OR statement. So in the union, I'm going to shade in anything that was shaded in at least one of the number lines. Basically, anything shaded in the first one, anything shaded in the second one, all that stuff gets shaded. So when I do that, well, the bottom number line shades in everything up until 8. And then the top number line takes care of all of the rest. It takes care of all the rest. So that means everything gets shaded. In other words, all the values of x ended up working. That's a little weird. Everything got shaded, but that can technically happen with a number line. Okay, so one final problem for us to work out in this video. Again, I'm going to just flip some of the inequalities. Okay, so number line. First, I got x is bigger than 2, so it cannot be equal to, so open circle. Bigger than means shade the stuff to the right. And then x is bigger than 8, so it cannot be equal to 8, so open circle. And then bigger than 8 means the stuff to the right. Okay, so I'm going to combine it with the word and, so that means intersection. So I'm going to shade in the stuff, just the stuff that's common to both of the number lines. The stuff that's common to both is only the stuff to the right of 8. Only the stuff to the right of 8 was shaded in both. Was 8 shaded in both? Well, no, it wasn't shaded in the bottom one, only the top one, so it remains open. Okay, so that's my AND statement. That's my intersection. Okay, now the second part, the OR statement. Let's make their union. Basically, I'm shading in anything that's shaded in either one of the number lines. Okay, so overall, everything that's to the right of 2 ended up getting shaded in the top one. In the bottom one, everything to the right of 8 gets shaded. Well, that would just make me reshade some of the stuff I already have shaded. Okay, so that's not going to change anything. And that's my union. That's what I get if I combine them with a union.